In this video, I'll demonstrate how to utilize OCI's cloud-native Zero Trust Packet Routing Service, also known as ZPR. This allows you to prevent unauthorized access to your resources with an easily understood, intent-based policy language. We'll use a VCN with two subnets. The first subnet will be named Source Subnet, with a single instance named Source Instance. We'll also have a subnet named Destination Subnet, with another instance named Destination Instance. The goal is to establish bidirectional connectivity using only Zero Trust Packet Routing policies. So let's begin. For testing connectivity between the two instances, I'll just use the ping ICMP echo commands. Now I have my VCN, subnets, and default security lists created. And what we'll do is we'll verify that we do not have echo enabled for ICMP in our default security lists, and we don't see it there. And I'll also go to my instances and test connectivity as well. I'll run a ping command from my source instance to my destination, which is unreachable, and I'll switch to my destination instance and perform the same command just in reverse back to the source instance, also unreachable. Now let's use ZPR policies to correct this issue. From the Oracle console hamburger menu on the top left, let's navigate over to our Zero Trust Packet Routing main menu. Now from this page, the first thing we'll need to do is create a namespace to hold our security attributes. So let's select Security Attribute Namespace, and then let's click the Create Security Attribute Namespace button. Alright, let's fill in a name. Mine will be source and destination along with the quick description. And then select the Create button. Once the namespace is created, we'll need to create our actual security attributes that we use to build our policies. So to start, we'll create our first security attribute. And this will be for the VCN itself. So I'll provide its name, a description, and I'll use the static value, which will allow us to change the value later once we apply it to the source. Now let's create one more security attribute, and this time it will be for our instances themselves. Provide a name, a description, and this time I'll select a list of values, and the values will be statically defined here. One will be for the source, and the other will be for the destination. Okay, and once this is filled in, let's go ahead and click the Create button. Once finished with your security attributes, let's head back to the ZPR main page and then click on Policy to create the actual policy itself. Click Create Policy and provide a name, a description, and then click the Add Policy Statements button. When building ZPR policies, we can use the Policy Template Builder to quickly create policies based on common use case scenarios, like in our example, where we have two compute instances within a single VCN that needs to communicate with each other bidirectionally. Note that each policy statement is for a data flow in a single direction. As shown, we read the policies from left to right, which states that the VCN that contains our source compute will be allowed connectivity to the destination compute. So if I were to replace this with my security attributes, it will look like the following. If we need connection initiated from the other direction from the destination endpoint back to the source, we'll need a policy statement for that as well. Once finished, click the Add button followed by the Create Policy button. Now we need to head over to our resources and apply the appropriate security attributes based on the resource type. So starting with my VCN, I'll go in and click Add Security Attributes. I'll select the namespace that was created earlier, followed by my VCN key, and then the value I'll put here is demo VCN. Then I'll click Add Security Attributes. Now I head over to my source instance and I'll do the same. This time I'll go to the Security tab, click the Add Security Attributes. Once again, click on my security namespace. My key was selected, and from my list of values, I'll select source, followed by Add Security Attributes. And last, I'll do the same thing on my destination instance. Add Security Attributes. Key is selected correctly already, and then I'll select destination as the value. Add Security Attributes. Once finished, let's go and verify connectivity. ZPR policies also require a corresponding security rule that allows access based on the IP address and protocol being used. So if I go back to my default security list, you see that I now have a security ingress rule that allows communication between the VCN over ICMP over any type and code. Now I'll head over to my source instance and I'll kick off another ping. And I'll do the same thing for my destination instance as well. Okay, immediately I have replies from my destination. If I circle back to my source, I have connectivity there as well, proving that our ZPR policies are now taking effect. This concludes the demo. Thank you so much for watching.